Hello and welcome to this lecture, which is about the analysis of quantitative data. So this is quantitative research number 2. And in the last lecture, we learned a lot about how to collect data mostly. We also learned a little things about variables, which will be also very important in here because depending on the type of variable, the type of analysis is different. So maybe we can start with some important concepts that you need to know. And here I want to clarify a few things that maybe we use sometimes in normal life. You see this in the news and they use these concepts incorrectly, probably, but it's important that we understand the meaning of all of these three first concepts. So first, let me start with the concept of statistics. And I know that maybe you hear statistics in the news again, or when you talk with your friends or something, and maybe you are using in a different context from an academic context, but in the context of research, this is kind of the broad definition or the broadly accepted definition of what is statistics, which is a body of methods and theory that are applied to quantitative data. So it is a mix of methods and theory. So that's something very important. You can't have statistics if you don't have theory behind it. And so I think that might be the biggest difference to what we understand normally as statistics, that it is actually supported by theory. So it's a combination of methods and theory that you apply to quantitative data to analyze it. Then we have statistic without the S, only statistic. And statistic is defined as a number that describes a sample. So here the important thing is this, the sample. In a statistic belong to a sample. And the difference is that if you have a number that belongs to the population, then it's a parameter, not a statistic, but a parameter. So be careful with that difference. It's kind of a technical difference, but we need to be careful with that. So every time that we refer to the sample, we are referring to a statistic. And when we are referring to the population, we're referring to a parameter. So let me give you an example. Like maybe if we want to have if we are talking about the average age of a sample of high school students, for example, in Sweden, we have, again, making up numbers, 200,000 high school students. If we know the average age of 20,000 students, high school students, that is the average age of the sample of only 10% of the students. So that will be a statistic. But if we can have access to the whole population and then we calculate that average, we will be able to have the parameter. So the parameter is if we know everyone, the 200,000 students age, okay? But here is an important thing. So sometimes we can assume that the statistic can be used as a parameter. Like we can assume if certain conditions and assumptions are met, that the average of those 20,000 students, the average of age of these 20,000 students are also the average age of the total, the 200,000 high school students. And the main assumption behind this, that we can interpret the statistic as a parameter, is if their sample represents the population. That's why I talk about it in the previous lecture, that was super important, that your sample represents the population. And the other thing is that this sample has to be totally random. Like it has to represent it, and also it has to be random. Like if you select it manually, like the sample, because, or if you do it biased, if you select that sample bias, is not going to work out. It has to be randomly selected or randomly created, that sample, and also that it represents the population. There are a lot of statistical tests that might help you to find this, and there are a lot of assumptions behind it. But the most important thing is if you go to the basics, like if you actually reflect and you actually make a conscious effort to note if your sample represents the population. That's why I think research design in a quantitative research is so important, because you can show that your sample represents your parameter if you have a good research design. And that underpins everything, because all the statistics that we are going to learn, or the analysis that we are going to make, assume that you will have a good sample, and then you will be able to draw conclusions about the population. So if you don't have a research design, nothing's going to work out, because even if you are the best at statistics, you will be only calculating things for your population, which is pointless, because in the end, you want to draw conclusions from the population and not the sample. So the very, very important that we understand the differences, and that we understand the assumptions of when and why a statistic can be interpreted also as a parameter. Okay, so let's move on to other important concepts. And this is kind of the agenda for today's lecture, that we are going to start with descriptive statistics, which this sounds like the easiest thing about statistics. It is actually maybe easy, but it's super important, and we need to know how to use it. It's also very powerful to use descriptive statistics. So we're going to talk about this at the beginning. Then we're going to move to inferential statistics. This is in descriptive statistics, you use this kind of statistics to, as it says, summarize, describe, or display quantitative data. And the inferential statistics are more about finding relationships, about building, drawing conclusions, about testing ideas. So this is a bit more complex. And in this field, we have kind of, in both fields, actually, we have kind of different analysis depending on the variables that we have. If we only have one variable, or we analyzing each variable independently, we will be talking about one variable analysis, and it's mostly descriptive statistics. And then we move to when we want to relate two variables, and this is the two variable analysis. And in here, we're going to learn a few tests. Well, it's kind of the introduction, because if we don't have enough time to do everything, we're going to learn a lot in the quantitative. That's the purpose of the quantitative lab, like more like how to do it. But here I'm going to introduce you to some tests and some statistics and analysis that you are going to use when you have two variables, which can be maybe your thesis, or or what you are going to do in your thesis. And finally, what happens when you have more than two variables. That will be the multivariate analysis. And probably this is what you will use in your thesis if you're doing a quantitative study. It's, I think, 95% of what you are doing, you will end up in here, but probably you will pass through this to end up in here. So in the next video, we will start with descriptive statistics.